So we have learned about epsilon closure of a state. Now we are going to learn how to convert a regular expression into NFA and then NFA to DFA. So epsilon closure of a state, it is defined as a set of states that are reachable from that state by walking on epsilon transitions, including that state. So this we need to remember because this is very important. We require it. Question is given, design NFA and convert it into DFA. Regular expression is a plus b the whole star dot a. So this is a regular expression that is given to us. So first step is convert the regular expression to NFA. So first we are going to convert this regular expression into NFA. So first we'll draw a plus b the whole star, then followed by a. So we start with, so first a, so we'll draw a plus b first. This is a plus b. So epsilon on both the sides. This is a plus b. Then it is star. So one epsilon after, one epsilon before, then one to repeat. So this is one to repeat and one to skip. A plus b the whole star means epsilon should also be included so that we can skip and directly move ahead. Then followed by a. So we'll have single a, then only we can reach the final state. So from the question, we can understand that this will accept all the strings ending with a. So sometimes you can get a question, write a regular expression for a set of all strings ending with a. So first the expression will come, then you convert it into NFA. So we write the numbers 0, 1, 2, 3, 4, 5, 6, 7, and 8 is our final state. Now we need to convert this NFA into DFA. So there's a process that we follow. We start from the start state. So in this case, 0 is the start state. Then we calculate the epsilon closure of the start state. So in this case, we'll calculate for 0. So we start from 0. Epsilon closure of 0. First, we start with the state 0. Then on getting epsilon input, we can reach 1. 2 epsilons, we can reach 2. Another state 4 can be reached by 2 epsilons. So if you see here, epsilon epsilon gives us 4. We cannot reach 5, 3, that is not reachable. From 0, we can reach 7. So that is reachable. So 0 to 7 is reachable. So we write here 7. 8 is not reachable. So these many states are there. Now next column. So first we made a column for the state or set of states. Then Y is a column which is taking care of epsilon closure of X. So whichever input will come here, you write epsilon closure of that input. Then transition from Y on getting A. So all the states, we will check all the states for getting A as the input. So transition from Y, so 0 on getting A as the input, there is no transition. 1 on getting A as the input, there is no transition. 2, yes, on getting A as the input, there is a transition. So that transition is 3. So we write the state where we reach on getting A as the input. 4, if you get A as the input, there is no transition. Then 7, on getting A as the input, there is a transition. Yes, it moves to 8. So we get a set of states. 3 and 8 is a set of states that we reach on getting A as the input. Then next state, next column is transition from Y on getting B as the input. So on getting B as the input from 0, there is no transition. 1, there is no transition. 2, there is no transition for B. 4, there is a transition that includes 5. Only one transition is there for B. Now what we have to do, we start with 0. Now the new states that we get 3 comma 8 and 5. So we have to write them down. 3 comma 8 and 5. Now we will calculate epsilon closure of 3 and 8. So it is epsilon closure of 3 union epsilon closure of 8. So epsilon closure of 3, if we see here, first start with the state 3. From 3, we can go to 6. From 6, we can go to 1. We can go to 2. We can also go to 7. All these transitions are possible. We cannot move from, the arrow should be properly mentioned. We cannot move from 6 to 5. That is not possible. So 3, 6, 1, 7. All these are possible. For 8, the state only should be included, nothing else. Now we will check all these states for transition on getting A as the input. So a trick here is, from the diagram you can make out where the inputs of A are on 2 and 7. If 2 and 7 are included, then we can write the state next after 2. Like 3 is there and 8 is there. So 2 and 7 are included, we get 3 and 8. And 4 also should be included because from 1 we can reach 4 as well. So 4 also should be included. So we'll have 4, 7 and 8. So we'll have 4, 7 and 8. Now, if you see here, B transition is from 4. So here 4 is included in the set of states. So we'll get a transition to 5, from 4 to 5. Now epsilon closure of 5. So start with the state 5. Then we can go to 6. Yes. We can go to 7. Yes. We can go to 1. Yes. We can go to 2. Yes. We can go to 4. Yes. Can we go to can we go to 7? Yes, 7 already we have reached. We cannot go to 8. So these are the states. So 5, 6, 7, 1, 2, 4. Again, transition from Y on getting A as the input. Again, the trick. Check for the states 2 and 7. If they are present, yes, 2 and 7 are present. So we'll get the same combination 3, comma 8. Then we have 4 also. So 5 also we will get. So we are getting 3, comma 8 and 5, 3, comma 8 and 5, 3, comma 8 and 5. So these many states we are getting. No new state gets generated. If there is a new state getting generated, we have to include it on the column of X. Till all the states get covered, we are supposed to include it in the column of X. Now in this case, only 3 states are getting generated. We'll name them as capital A, capital B, and capital C for our convenience. Then we will draw a table. This is converting it into DFA. So we have 3 states, A, B, and C. A state is the start state because it is including 0. B and C are there with us, which are the new states that get generated. Now, how to check for start state and final state? So start state will have, in the epsilon closure, the start state would be there. So A becomes the start state. In final state, epsilon closure, the final state will be included. That is 8 is included in 3 comma 8. So B becomes final state. Now 3 comma 8 is renamed as B. 5 is renamed as C. So we can write here B, C. The transitions remain the same for all the states B, C, B, C. So this is what we are getting. So this is a table for NFA. So for a DFA. From NFA, we have converted into DFA. So what has happened here is, what we are doing, is we are renaming the states, and then we are writing the transitions. For each input, there is only one transition. Here, if you see, there are two transitions on A as the input. So this is an NFA. DFA means exactly one transition. So what we are doing is we are renaming it as B, but it is a combined state 3, 8. So we need to combine it here. So we are getting A, B, and C. Then after that, we can minimize it. In this case, it is possible. So classical method means you have to check the transitions BC, BC, BC. So we all three can be minimized. No, there is a catch here. What you have to do, we can merge only final states and non-final states only. So A and C are non-final. We can merge them. We cannot merge with B because B is a final state. So merging is possible if we have the same transitions and they are either non-final or final. Suppose we were having D as the state with the same transition, we could merge B and D. In this case, D is not there. A and C is possible. We rename it as X. So we have to draw another transition table, which will be a minimized version of this. So what we are doing is we have started with the regular expression converted into NFA. NFA is now converted into DFA. Now we are minimizing this. So A and C are renamed as X. So we'll have only one state X. We are combining A as the input, B will be remaining. B is the final state. So we'll have to mention B. Now C has been replaced by X. So we get X here. Here also we get B and then we get X. So these are the transitions. Now we cannot combine them even though the transitions are same because they are final and non-final. Now from this transition table, we will be drawing the transition diagram. So how do we draw the transition diagram? So we start with X as the start state. Then B is the another state. So on getting A as the input, we reach B. Then from X to X on getting B as the input. Then suppose we get B in B, suppose we get A. So we'll stay in the same state. And suppose we get B, we go back to X. So this is a minimized version. Now the regular expression given to us was A plus B the whole star followed by A. So that was the regular expression given to us. What it meant was it will accept all the strings ending in A. So if you check the transition diagram, suppose we get single A. So we will reach B, which is the final state. So final state shown by double circle. Suppose we get ABA. So we'll move A, B, A. So we'll go back to A. And we'll go back to B, which is the final state. Suppose we get AA. So we'll move from X to B followed by A. Suppose we get AB, AB, AB. So we move from X to B. So B to X, again X to B, B to X. So we are in X, which is a non-final state, which indicates that we are not accepting the string. So this is also very important. So this is the way in which you can just verify whether your answer is correct or not. I hope so it is clear. So more and more practice is required for these type of problems as there are number of steps involved. So what we have done in this problem is regular expression was given A plus B the whole star dot A. We converted into NFA. Now NFA is converted into DFA. First we made a table with X. Y is epsilon closure of X. Transition from Y on getting A. Transition from Y on getting B. Suppose we were having C also. We'll add one more column. Transition from Y on getting C. Then we have drawn the table for DFA. So we are having three states and transitions for those three states. And then we check for any minimization if it is possible. So minimization was possible in this case. So we have merged A and C as X. And then we have drawn this transition table and converted into a transition diagram. So regular expression to NFA, NFA to DFA, and then to minimize DFA. So such problems can be asked for 8 to 10 marks. So it's very important to practice these problems. I hope so it is clear.